All right, so we're ready for lesson 16. This is great. I got a green shirt on, so I got the fish swimming right across me. Oh my God, this is great. I love it. So anyways, we're going to start. This is all pre-calc stuff right here. This is all stuff that you're going to see next year in pre-calc. Told you guys at the beginning that I want to make sure that I get you guys ready for pre-calc. And here we go. So we're going to solve some first degree trig equations. All right, so what does first degree mean? All right, remember from way back in chapter 3 and 4, way back when we first started our wonderful adventure together, we did first, second, third, fourth, fifth degree polynomial functions. First degree just means that the variable that we're solving for is to the first power. All right, so these are going to be pretty basic, straightforward trig equations. They're going to be first degree, and we're going to solve them. So just one thing to know, for all of our equations, we're going to solve for theta most of the time, which is the Greek letter that's used most of the time in trig. And theta is going to always be between 0 and 360. So what that means is all of our answers that we get are going to be between 0 and 360. We're never going to go outside that realm. Because the bottom line is this: if you get an answer of 30 degrees for something, there's actually an infinite number of answers, because 30 is really negative 330. It's also 390. There's a infinite number of angles that are the same as 30 degrees. So to prevent us from having to list an infinite number of answers, we just always want to pick answers that fall between 0 and 360. That way we don't have to sit here and just keep listing answer after answer after answer after answer. So all of our answers are going to fall between 0 and 360. All right, so let's just establish that. All right, so I'm going to go through 4 example problems of first degree trig equations and show you how to solve them, and then you'll do some homework. All right, so we'll get that started. So here is our first degree trig equation. It's 2 cosine theta minus 1 equals 0. Now, to make this easier initially for you guys, what I'm going to do is I'm going to go off to the side here or over here and just do it like with algebra, the way we usually do with algebra, and then you can see that it's actually the same stuff you've always done since you've been solving equations when you were in 6th, 7th, and 8th grade. All right, so if I take this equation right here and just forget the fact that's a cosine of theta, let's just switch it to an x for a second. In fact, I'm even going to write off to the side here, and I'm going to let x be cosine theta. So I can replace that cos theta with an x, and I'm just going to solve for x like we've done forever. So to do that, I got to add the 1 over to the other side, and I get 2x equals 1. Divide both sides by 2, and I get that x equals 1/2. Now remember, x is cosine theta. So I'm just going to take that x, get it out of there, and switch it back to cosine theta. So I have the cosine of some angle theta is 1/2. 1/2 should seem familiar to you. All right, that's something that we have on our 30, 60, 90 triangle. What angle do we know has a cosine of 1/2? All right, well, if you look, 60 degrees adjacent over hypotenuse, cosine is 1/2. So that tells us that our answer is 60, but that's not our only answer, because we have to remember that cosine is positive in 2 different quadrants. It's positive in A and C. So 60 degrees is our answer from quadrant A. So 60 degrees is one of our answers. Our other answer, though, falls down here in quadrant C. And if I take 60 and draw it as a reference angle in the C quadrant, I can see that that angle right there is actually 300 degrees. So 300 is my second answer. There's two answers to this equation, 60 and 300. Now, like I said previously, we can keep listing more answers. We could say negative 60 is an answer. We could say that 420 is an answer because you go around once and keep going. We're not going to do that. We're going to keep all our answers between 0 and 360 so that we can have a finite number of answers and not have to keep listing answer after answer after answer. So 60 and 300 are our two answers to this first example. All right, here's our second example. This time I got sine theta equals 3 sine theta plus 1. I'm going to do exactly what I did in the last example. I'm going to start by saying, all right, let's let x be the sine of theta. Let's switch this all over to x's so we can solve it like we're used to solving. And then I got bubbles. These bubbles flying everywhere. I love it. All right, anyways, so this is, we're going to call this x equals 3x plus 1. There, I've switched the sine thetas to x's, and I'm just going to solve this equation like we normally would. You got to get x by itself. Got to get x's all on one side. So I think I will subtract this 3x over here, call it negative 2x equals 1, divide both sides by negative 2, and I get x equals negative 1/2. That's just basic, simple algebra. All right, so remember that x is actually sine theta. So I'm going to switch that to a sine theta. And I have that the sine of theta is equal to negative 1/2. So that tells us that sine is negative. Where is sine negative? Not here, not here, but here and here. So I'm going to have two answers that are going to fall in the T quadrant and the C quadrant. All right, so what angle has a sine that's 1/2? Well, 30, 60, 90 triangle is going to tell us that. Sorry, a little sloppy here. But anyways, the sine of 30 is 1/2, opposite over hypotenuse. So we know that we're talking about 30 degrees. All right, so if we go to the T quadrant and put a 30-degree reference angle in there, and we go to the C quadrant and put a 30-degree reference angle in there, we're going to find our two answers. This answer right here is going to be 180 plus 30, which is 210. This angle right here is going to be 360 minus 30, which is 330. There are our two answers, 210 and 330. And that's because of the quadrant that they're in. Again, sine was negative, so it went to these two quadrants. We established that we were dealing with 30, put 30 in as a reference angle, found those two angles. Gonna do two more examples for you. All right, example 3. 4 times in parentheses sine theta plus 1. So once again, I'm gonna switch over to x's. Let x equal sine theta. Switch this to an x so that it's more like what you're used to seeing. We all know that when we have a number out in front of parentheses, we should distribute it in. So let's distribute the 4 in. So we get 4x plus 4 equals 0. Move the 4 over. I get 4x equals negative 4. Divide both sides by 4. And I get x is equal to negative 1. Remember though, x is actually sine theta. I'm going to switch that to sine theta. Now, sine of some angle is negative 1. Where would we find that angle? Anytime we're dealing with 1, negative 1, and 0, we're looking on the unit circle. So let's go to the unit circle and figure out what angle has a sine of negative 1. Remember, sine is your y value. What angle on the unit circle has a y value of negative 1? That's going to be right down here because the coordinates are 0, negative 1 when you're down here, and there's your sine value. This is 270. This equation only has one answer. There's only one place where sine is equal to negative 1, and that's 270 degrees. So we only got one answer for this one. All right, and that's because it was an angle on the unit circle, different than the other ones. All right, going to do one more for you. All right, last example. Hopefully this is enough to get you guys going on your homework. Once again, going to let x be sine theta. Switch these all over to x's so it makes it easier for us to solve. So if I'm going to solve this, I want to try to get x's all on the same side. I think it'd probably be easier to move this 3x over this way. So I'm going to subtract 3x over to this side. That's going to give me negative radical 3 equals negative 2x. If I divide both sides by negative 2, I'm going to get that x is equal to negative divided by negative is going to be a positive. That's going to turn into a positive radical 3 over 2. So switch x back to sine. Sine of theta is radical 3 over 2. Where would we find radical 3 over 2? Our 30, 60, 90 triangle, for sure. So let's put that up here real quick. Radical 3 over 2, we're talking about sine. Sine's opposite over hypotenuse. 60 is going to be the winner. 60 has an opposite over hypotenuse of radical 3 over 2. So we know it has to do with 60. But let's remember that this question has sine equal to a positive radical 3 over 2. So we're looking for places where sine's positive. That's going to be the A and the S quadrant. So we're going to use 60 in both of those quadrants. So let's draw a 60-degree reference angle here and a 60-degree reference angle here. The answer from the first quadrant is simple. 60 is its own reference angle, so it's 60 degrees is one answer. But over here, that angle right there is going to be 180 minus 60, which is going to be 120 degrees. 60 and 120 are our two answers for this question. Done. Now, the only other thing that could change with all this is maybe your answers need to be in radians. Piece of cake. You could take your answers and swap them over to radians if you need to, if the question tells you that. So let's say, for example, this problem I'm doing right here wanted your answers in radians. All right, no big deal. We can take 60. I'm going to do erasing here. We can take 60 and 120 and convert them to radians. So to convert to radians, you just take your answer and you multiply by pi over 180. Instead of 180 over pi, you're going to do pi over 180 because you want to get back into radian measure. So we can reduce this. 60 goes into itself once. It goes into 180 3 times. We would call this pi over 3 radians. Over here, 120. If I put that over 1, multiply by pi over 180, reduce. 60 goes into 120 twice. It goes into 180 3 times, looking like 2 pi over 3. So there would be your answers if you wanted them in radians. You don't get asked that very often, but if you ever had to switch your angles over to radians, that's how you do it. All right? Got homework coming for you. Got fish swimming everywhere. This is fantastic. Raiders on 3.